Ever wondered why blue is so rare in nature? Well, you're about to find out. Blue, an enchanting hue that captivates our eyes and stirs our souls, is surprisingly scarce in the natural world. From the vast expanse of the sky to the depths of the ocean, instances of true blue are few and far between. Most plants, animals, and minerals lack the ability to produce blue pigment. Imagine a peacock's dazzling display or a butterfly's iridescent wings. Their blues are not the result of pigmentation, but a clever trick of light. This is a fascinating revelation, isn't it? Our perception of blue in nature, more often than not, is merely an illusion. Yet this only adds to the allure of blue, making it one of the most intriguing colors in our world. So if blue isn't a pigment, then how does it appear in nature? The answer lies in the physics of light. To understand why blue is rare, we need to delve into the science of light. Light, in essence, is a form of energy that travels in waves. When light waves hit an object, they bounce off, get absorbed, or pass through it. The color we perceive is the light that is reflected back to our eyes. Now let's talk about blue. Blue light has a shorter wavelength compared to other colors. It's a bit like the energetic youngster of the light family, buzzing around, bouncing off particles in the atmosphere and scattering in all directions. This scattering phenomenon is why we see a blue sky on a clear day. However, when it comes to objects, most cannot reflect blue light because of its shorter wavelength and higher energy. Instead, they absorb it, or let it pass through. This is why we don't see as much blue in the natural world as we do other colors. Now that we understand light, let's see how it creates the illusion of blue in nature. Nature has a way of creating blue without the blue pigment. It's all about illusion. Let's take a moment to dive into the world of the morpho butterfly, an incredible example of how nature bends light to its will. The morpho butterfly, with its iridescent blue wings, is not truly blue. Yes, you heard it right. It doesn't have a single grain of blue pigment. Instead, it uses something far more fascinating: microscopic structures on its wings. These structures are so tiny that they can interact with light waves. When light hits these structures, it gets scattered in all directions. However, only some of this light reaches our eyes. The blue light, to be precise. This scattering of light creates an optical effect, causing us to perceive the wings as shimmering blue. This is not a true blue pigment, but an optical effect known as structural coloration. It's like a magic trick that nature has up its sleeve. A sleight of hand, or should we say, a sleight of wing. But the morpho butterfly is not alone in this. A few other species, like certain birds and insects, also employ this trick. They use structural coloration to create the illusion of blue, without any blue pigment involved. It's fascinating, isn't it? But the question remains, why is blue so rarely used this way in nature? Despite its beauty, blue remains a rare spectacle in nature. It's puzzling, isn't it? This captivating color that paints our skies and oceans is surprisingly scarce among plants and animals. There are a few theories that attempt to explain this rarity. One suggests it's because of the energy cost associated with producing the structural coloration that creates blue. You see, unlike other colors that are directly derived from pigments, blue is often a result of intricate structures that manipulate light. This process is more energy-intensive and thus less favored by nature's economical ways. Another theory points to the risk associated with visibility. Blue, being a vibrant and easily noticeable color, could potentially attract unwanted attention from predators. This could explain why nature, in its endless quest for survival, might opt for more subdued shades. However, despite these compelling theories, the rarity of blue in nature is still largely a mystery. It's a testament to the complexity of our natural world and the endless puzzles it presents us. It's fascinating, isn't it? This color that we often take for granted, the color of calm and tranquility, is one of the most complex and elusive phenomena in nature. It's not just a color, but a masterstroke of physics, a result of evolution's careful choices, and ultimately, an emblem of the extraordinary beauty and complexity of our world. So there you have it. Blue, the most elusive and enchanting color in nature, is a result of light physics and evolutionary choices. A remarkable example of nature's ingenuity.